Hello students, welcome to our discussion of inventory management from chapter 16. We're going to look at ways for companies to determine their best order quantity. How much should they order? We'll look at when they should order it and what will their total cost be after, once they order the product, and how to minimize their cost. So go through some principles, and then we'll go through an example of this. So the role of inventory, as it says there, we're keeping items on hand used to meet customer demand, anticipated demand. We're going to look at, in this chapter, we're going to look at one basic model of the order quantity. What should be the economic order quantity that will minimize total cost for the business? Demand, we're going to assume demand is known, that it's predictable. Demand can be external, can be internal, but our model that we're going to follow basically works with that known demand. There's two types of inventory costs. One is a carrying cost. This is the cost of holding items in storage. Generally, it's expressed as a percentage or as a cost per unit. And that's one of the two costs that'll make up our total cost. The second cost is an ordering cost. This is the cost for replenishing the stock of inventory. There's going to be a cost to order your items, usually as expressed as a dollar amount per order, independent of order size. So it doesn't matter how much you order, it's going to be it's not the cost of the items you're ordering, but the actual cost of the shipping and handling, as it says there. How much is it going to cost to bring the product in? So we're going to look at the basic economic order quantity, EOQ model, for this chapter on inventory management. So the economic order quantity, EOQ, is the quantity ordered when inventory decreases to the reorder point. So during the business cycle, you're going to have, at the beginning, you're going to have all your inventory. You're going to use up that inventory as you make your product that you're selling. So there's going to come a point of time in which you need to reorder in order to ensure that you do not run out of supplies needed to make your finished product. So we're going to look at the economic order quantity. We're going to look at when you should reorder the product, and kind of how often we're going to make that purchase. The basic economic order model is a formula for determining the optimal order size that minimizes both carrying costs and ordering costs. So it minimizes your total cost. In this model, demand is known with certainty and is relatively constant over time. No shortages are allowed. There are other models that allow for shortages or allow for probabilistic demand, but we're going to just work with this one model. The lead time for the receipt of orders is constant, and the order quantity is received all at once and instantaneously. Let's go through this. Basically, the inventory order cycle. Say at the very beginning here, point 0, you have your order quantity Q. Throughout time, you're going to be using up some of your inventory based on the demand rate. You're going to hit a point right there where you need to reorder, so that when you get down to 0, you have sufficient lead time built in to actually receive your product, and your product comes, and then it carries on through being used through based on the demand rate over time. So the carrying cost, we're going to go through these formulas in an example that we'll work on, but the carrying cost per unit is expressed as capital C, lowercase c. That's basically mean the carrying cost per unit per year. It's based on the average inventory. Because demand or the inventory is used up equally over time, then we calculate the average inventory and we multiply that by the carrying cost per unit, and we'll get our carrying cost. The ordering cost, so total annual ordering cost capital C sub O for the ordering cost. Basically, the annual ordering cost is CO multiplied by the demand, annual demand, divided by the order size. We put those two formulas together, we'll get the total annual inventory cost. It's the sum of both of those costs separately, the ordering cost and the carrying cost. So we'll look at this example, an example of this. We'll come to this as well here. So, well, before that, one thing we want to do is determine what's the best order quantity. Q is the the amount that we're going to order. So the economic order quantity is that quantity that's going to minimize our costs. If we order too much or too often, we're going to increase our total cost. So we want to order that point Q, that economic order quantity Q, at which to the point that it'll minimize our total cost. So our Q optimal is the square root of 2 times the order cost times the annual demand over the carrying cost. And that will give us the optimal level of Q, how much we should actually order, that will minimize our total cost. Some of the examples that we'll work on will be comparing different businesses' different ordering amounts, and how it changes the total cost, and how it changes other business costs as well, and other business characteristics, and how if we were to order the optimal amount, how we can actually see that's going to minimize costs and going to make the business more efficient. So here's an example that we'll work on. This is from the course notes in chapter 16. Carpet company, number of orders to be made annually, and time between orders given the store is open every day except Sunday, Thanksgiving Day, and Christmas Day. So it works out that there are 311 working days. We need to know the number of working days when we calculate the order cycle time and the reorder point. Lead time is 10 days, and we'll need to know that when we calculate the reorder point. If it takes 10 days for inventory to arrive, we need to know at what point of our inventory do we have enough inventory to last 10 days in order for inventory, new inventory to be received just as we need it. So the model parameters, the carrying cost is 75 cents per item, ordering cost is $150 per order, and the annual demand is 10,000 yards. What we want to calculate is the optimal order size, Q, as well as the total annual inventory cost, the number of orders per year, and the order cycle time. So let's take a look at how we can do that. Let's go into here. So the economic order quantity. So the first thing we want to calculate is, I'm just going to abbreviate this Q asterisk. It could be Q optimal. Basically, this is the formula where it is the square root of 2 times the ordering cost times annual demand over the carrying cost. So this works out to be 2 times ordering cost of $150 per order, annual demand is 10,000, and the carrying cost is 75 cents per unit. So we calculate that, we will get 2,000. So if they order 2,000 units, 2,000 yards I think it is, that will be the order amount that will minimize our total cost. So let's calculate our total cost. Total cost from the previous formula, or previous slides, is our order cost, CO, times annual demand over whatever we order, over Q, plus the carrying cost times economic order divided by 2. make this calculation, we will get 150 times annual demand is 10,000. We're ordering 2,000 plus 0.75 times 2,000 divided by 2. Sorry. This works out to be 750 plus 750 equals $1,500. And that's what we'll find when we actually put in the optimal level of Q to our total cost calculation, that both costs are minimized and both costs are equal. So that's two of the costs that we can calculate. We can also calculate, let's go back to our PowerPoint slides here, calculate the number of orders per year and the order cycle time. Orders per year. This will be annual demand over what we order. So 10,000 divided by 2,000, we have 5 orders per year. And order cycle time is based on this formula. We have the working days, which we know is 311 divided by the orders per year, D over Q. So we have 311 over 5. That equals 62.2. So we should reorder. Yes, you will order every 62.2 days. Next, let's calculate the reorder point. The reorder point is R equals the daily demand times the lead time. So daily demand is 10,000 units divided by 311 times our lead time of 10 days. So 10,000 units divided by 311 days times 10 days gives us 321.54 units. Basically, that tells us that when our inventory gets down to that point, that's when we should place that order. Then over the next 10 days, our order will go down to 0, but just as it hits 0, we get a new order of inventory items, and we're back to that full level. So we're going to order every 62.2 days. We're going to reorder at when our inventory gets down to 321.54 units. We're going to place 5 orders per year. By doing so, we will have a total cost of inventory cost of $1,500 over that year, and we order 2,000 units. So going forward with this, whenever we calculate that optimal level of Q, if it's not a whole number, we're going to round up. Round up to the nearest whole number. Doing so is going to create a total cost that's not going to be perfectly minimized, but we can't order a fraction of a product, for example. So we always round up the Q optimal to the whole number. Also going forward, some things that we can ask is we can compare this model to the current model. What would the model look like in terms of the total cost, orders per year, order cycle time, and reorder point if we ordered, say, 2,500 units per year? One of those costs are going to be lower. One of those costs in our inventory costs can be lower, but one's going to be higher, and we might be ordering more per year. So that's a good comparison for this chapter.